Hello everyone, this is Vanshi Pathak. Today in this video, we will be solving internal 3 question paper of data science. So let's start. The question number 1 says that discuss attribute by attribute problems that may have found into the following data set. So here we are supposed to find the errors from the data set. So there are total 7 attribute: customer ID, zip, gender, income, age, marital status and transaction. We will check attribute by attribute if there are errors in the dataset or not. In the first attribute, customer ID, the variable seems to be fine. There is no such error. But in second attribute, zip, there are a couple of errors associated with customer ID 1002 and 1004. Here we are expecting all of the customer in the database to have usual 5 numeral zip code, but the customer ID 1002 has zip code which includes alphabets as well, and the customer ID 1004 has zip code only including 4 digits. That's why there are few errors in this attribute which we need to handle. In the gender attribute, there is a missing value associated with customer ID 1003. So we need to handle this missing value with the help of mean, median or random distribution, or by user defined constant, because the missing values may cause error, may cause problems in further processing of the data. And fourth attribute, income, there are errors as well. The income of customer ID 1002 is in a negative number, which is definitely not possible, and for the income of customer ID 1003 is a very large number. It is an outlier, and we know that and we know that statistical methods and modeling techniques may not work smoothly with outliers. That's why we need to handle outliers as well. Now, in the age attribute, every member has age in a numerical value except for the customer ID 1001. It has age in a alphabetical value, which is definitely not possible, and the age of customer ID 1004 is 0. The marital status attribute, there is no such error, but there are problems associated with the meaning of these symbols. Like this attribute seems to be fine, but the problem lies in the meaning behind the symbols. And in the last attribute, transaction, there is no such error, it is fine. These were few errors in the data set which we need to handle. Now moving towards the question number 2, apply data wrangling process in the following database. Here is the database. We need to perform data wrangling. Data wrangling is nothing but a process in which we convert the raw data into a usable or more understandable format. It is also known as data munging. So let's move toward the solution. The data wrangling process. Here we'll format all the name in the way first name, comma, last name. First we will write the first name of the person and then we will write the last name. The phone numbers are formatted in the same way, like every phone number must contain 10 digit, not more than that or not less than that. And dates are formatted numerically. First we'll write the year, then we'll write the month, and then we'll write the date. Now in the states are not abbreviated. We'll write the full name for every state. We will not use abbreviations. Here in the below data set, we have removed the data of Jackie Agarwal because it do not have fully formed data. As we can see, the data associated with Jackie Agarwal is not complete because the phone number was not in the specified format. It contains 8 digit only, 7 digits only, and the birth date doesn't include year. That's why we have removed the data of Jackie Agarwal. So the resulting data set is cleaned, readable for the deployment or evaluation of the data set. Now question number 3, consider the following database, apply any three methods for finding out the missing values. Here we are supposed to handle the missing values with three methods. First is user defined constant, second is mean median mode, and the third one is a random draw from the distribution of the variable. So let's see. In the first method, we are replacing filled values with the random draw from the distribution of variable. Here we have replaced the value with random distribution of the variable. In the second method, we are replacing the missing field with the user defined constant. So for numerical data, we have specified 0 as a constant, and for alphabetical data, the user defined constant is missing. Third method is replacing missing field values with mean or mode. For numerical data, we'll replace the missing field with the mean of all the values, and for alphabetical data, we will replace the missing field with the mode value. As we can see here, US has occurred twice, that's why we have replaced the missing field with US. And question number 4, classify bank loan application by assigning applications to one of the three risk classes. There are three risk classes A, B and C. So we need to classify them into any of the three risk classes by using entropy and information gain approach. Here's the data set, and the frequency of class A is 3, the frequency of class B is 3, and for the frequency for class C is 4. Now here we are calculating the entropy of whole data set, which is 1.57. Now after this, we'll calculate the entropy for each of the individual data, each of the individual attribute: own home, married, gender, employed and credit rating. We'll calculate their individual entropy and the information gain and plot them in a tabular format and write them in a tabular format. And as we can see, the gender attribute has highest information gain value, that's why we will select it as our splitting attribute. And now we can reduce the data by removing the attribute gender because it has been selected as our root node. And after removing the gender class, this is the remaining reduced data. Now we will apply the same process on the data set. We will calculate the entropy of whole data set, and then we will calculate individual entropy and information gain for all the attributes. Here we can see that the married attribute has entropy 0.00 for yes and entropy 0.00 for no. That's why there is no need to consider other attributes now, because no other attribute could be better than the splitting attribute married. So in this step, we will consider married as our splitting attribute. So this is the final decision tree, and these are the rules generated from the decision tree. Now moving towards the next question. Compare the attribute for classification of bank loan application by assigning applications to one of the three risk classes, but here we are instructed to use gain index approach. In the previous question we have used information gain method, but here we'll be using a gain index method. See, the data set and frequency for the classes is same as the above. A class has occurred 3 times, B class has occurred 3 times, and the frequency of class C is 4. Now we will calculate the Gini and Gini index value for all the individual attributes, and we will write them in a tabular format like this, and then we will compare the Gini index value of all the attribute. In the information gain method, we have selected the attribute which has highest information gain value, but in gene index we will select that attribute as the splitting attribute which has minimum gene index method. Here gender attribute has minimum value, that's why it has been selected as the splitting attribute. And this is the final decision tree, and this is the rules of the decision tree. So that's all for today's video.